Hey everyone, and welcome back for another deep dive. This time, we're taking a look at language models.
Exciting stuff.
Yeah, it really is. So these language models, the things that power chatbots,
Yeah.
the ones you can like have a conversation with, and it almost feels like you're talking to another person.
Yeah, they're amazing.
They are amazing.
Yeah.
But one of the things that I always find kind of fascinating and kind of freaky is how they sometimes just make stuff up.
Right.
Like you ask it about something and it gives you all these details, but then you look it up and it turns out,
It never existed.
yeah, it never existed. And it's like, how do they even come up with this stuff?
Yeah, it's those moments that we call hallucinations, and it's when the model generates something that is incorrect or completely made up.
It can be so convincing too.
That,
Like sometimes it's really hard to tell if it's hallucinating or not.
yeah, it's a real challenge, and that's exactly what this deep dive is about.
This deep dive is all about trying to figure out what's going on inside these AI brains
Mm.
when they hallucinate.
Exactly, and the research paper we're looking at today is called Do I Know This Entity Knowledge Awareness and Hallucinations in Language Models?
Okay, so that title already has me intrigued. Knowledge awareness.
Right.
So the authors are Javier Ferrando, Oscar Obeso, Sentor and Rajamanoharan, and Neil Nanda.
That's right. And they're using some really interesting techniques to try and understand these hallucinations, especially when the model is asked about something it doesn't actually know.
Okay, so not just cases where the data is outdated or there's some kind of like mix-up, but when it's truly venturing into the unknown.
Precisely.
All right, so how do they even go about doing that? Like how do you peek inside an AI's brain?
Well, they use something called sparse autoencoders.
Sparse autoencoders. Okay, that sounds a little intimidating. Break that down for me.
Sure. So think of it this way. The internal knowledge of a large language model is kind of like a giant, messy library, right? There's information in there, but it's not neatly organized or labeled.
I can picture that.
And sparse autoencoders, or SAEs for short, are like specialized librarians.
Okay, I like where you're going with
They
this.
can sift through all that mess and find the exact books or shelves.
So they can actually pinpoint where the LLM stores its knowledge about specific entities.
Exactly.
Wow, that's really incredible. I mean, how do they even...
So this works because of something called the linear representation hypothesis. The basic idea is that interpretable features are encoded as linear directions in the representation space of LLMs.
Okay.
And SAEs find these meaningful directions by reconstructing the model's representations as sparse linear combinations of features, forcing them to be interpretable.
So it's like they're finding the hidden structure and all that chaos.
Exactly.
Okay, so how did the researchers actually use these librarians to figure out what's going on when an LLM hallucinates?
Well, they used Wikidata.
Wikidata.
Yeah, it's this massive database of information about basically everything.
Okay, yeah, I've heard of Wikidata.
They came up with all these prompts about different entities, movies, cities, songs, basketball players. Some of them were real and some were totally made up.
So they were trying to like trip it up, see if they could catch it hallucinating.
Exactly.
Clever. And did they find anything? Did the SAEs reveal anything interesting?
Oh, they sure did. They trained these SAEs to distinguish between prompts about entities the model knew and those it didn't.
Okay.
And what they found was fascinating. There were these specific latent directions that only lit up when the model was processing something it didn't recognize.
So it's like it had a built-in "I don't know this" signal.
Exactly, a form of self-knowledge, you could say.
Hold on. Are you telling me that these language models might actually have a sense of what they don't know?
That's what this research is suggesting.
That is mind-blowing.
And what's really interesting is that these entity recognition directions weren't just limited to one type of entity.
Oh, really?
They worked across categories, movies, athletes, cities, it didn't matter. It seemed to be a general mechanism for how the model was recognizing entities and assessing its own knowledge.
So it wasn't just about like knowing LeBron James or knowing a specific movie. It was about knowing what a known entity is.
Exactly.
Okay, so we've uncovered this "I don't know" button in the LLM. That's amazing.
Yeah.
But can we actually push this button? Can we control its behavior based on these latent directions?
That's a great question, and that's what we're going to be diving into next.
I can't wait. This is getting really interesting.
Welcome back. So before the break, we were talking about how researchers had found this, I don't know, signal.
Yeah, like the LL knew when it was about to make stuff up.
Right. And we're about to get to the really cool part, whether they could actually use this to control the model's behavior.
Yeah, can we like Can we make it not hallucinate?
Well, they did explore that, and it's called steering.
Steering.
Yeah. So think of it like you're kind of nudging the model towards certain responses. Like by tweaking these latents, they found they could make it more likely to just refuse to answer.
So instead of just making something up, it would say, I don't know.
Yeah, basically, and they mostly focused on the chat model version of Gemma 2.
Gemma 2, okay.
Yeah, because chat models are more likely to refuse a question, compared to the base models.
That makes sense. So how did they actually test this steering thing?
Well, they took a question about LeBron James,
LeBron James.
about his birthplace, and then they boosted the unknown entity latent. What?
The model said it didn't have enough information.
No way. But it's LeBron James, like everybody knows LeBron James.
I know, right? But that's what happened when they boosted the unknown entity signal. So even though it did know, it acted like it didn't.
Exactly. And they did this other thing, too, to make sure it wasn't a fluke. They created an orthogonalized model.
Okay, now you're just using big words to confuse me.
Sorry. Basically, they got rid of the I don't know button.
They, surgical removed it.
Yeah, so it couldn't write into that latent direction anymore.
Oh.
And guess what? The refusal rate plummeted. It basically couldn't say, I don't know.
Wow, so that really shows that Leighton was doing something important.
It really does.
So wait, if we can steer these LLMs, make them refuse to answer, maybe we can finally stop them from hallucinating.
Yeah, imagine that they just admit when they don't know something instead of making stuff up.
That would be amazing.
Yeah.
Especially when you're using them for something important and you need to be able to trust the information.
Right, exactly. This could be huge for making them more reliable.
Okay, so we've talked about tweaking these latents to make it refuse to answer. But what about the times when it doesn't refuse, but it still gets it wrong?
That's another thing they looked into.
Is there some kind of connection there too?
Yeah, they wanted to see if there were any latent directions that might show uncertainty even when it doesn't actually say, I don't know.
Huh. So, even though it gives an answer, maybe there's a little red flag inside.
Yeah, exactly. And remember earlier we talked about the model's attention.
How it focuses on different parts of the input.
Right, and how that can affect whether it remembers facts correctly.
Right. Yeah.
Well, they found a similar pattern here, too. They looked at what are called the residual streams.
Residual stream?
It's kind of like the leftovers after it processes the instructions in the prompt.
Okay.
And they compared the activation patterns for right and wrong answers.
So they were looking for a difference in its brain state right before it messed up.
Yeah. And they found that some latents were way more active when it was about to get something wrong.
So it's it knew it was on shaky ground.
Yeah, but it couldn't quite figure out how to say, I don't know for sure.
It's it's doubting itself, but it just keeps talking.
Yeah.
Yeah.
This is really important because if we can teach it to understand and communicate this uncertainty, then maybe we can stop those hallucinations.
It's giving it a way to say, hey, I'm not really sure about this, so maybe double check it.
Exactly. That would be amazing, right? Especially for those critical applications.
This is all so fascinating. We're really getting a glimpse into how these LLMs actually think.
It is pretty amazing how much we're learning about them.
It makes you wonder what else we might discover, right?
Definitely. It's a rapidly evolving field, and this is just the beginning.
Well, we've covered a lot of ground today, from hallucinations to steering and the role of uncertainty.
There's still more to come.
Yeah, in the final part of our deep dive, we'll explore even more mind-blowing implications of this research. We'll delve into what it means for the future of AI and how we interact with these incredible machines.
It's going to be good.
Stay tuned. Welcome back, everyone. It's the final part of our deep dive into the world of LLMs, and wow, we've covered a lot of ground.
It's pretty mind-blowing stuff, isn't it?
It really is. That LeBron James example still has me thinking.
Yeah, it really shows how much progress we've made in understanding these systems.
A few years ago, who would have thought we'd be talking about pinpointing the exact mechanism for knowledge and uncertainty in an AI?
Right. It would have sounded like science fiction.
Totally.
Mm-hmm.
But now we're actually seeing how we can use these insights to, maybe start shaping how these models interact with the world and how we can use them to solve problems.
It brings up some really interesting questions, doesn't it?
Yeah, we've talked about the tech side of things, but what does all this mean for the future of AI and how we relate to these machines that are getting more and more sophisticated all the time?
It's a big question.
It is. If an LLM can, on some level, know, what it doesn't know is that a form of self-awareness. How close are we to AI that thinks like us?
That's the big question, isn't it? I think it's important to remember that even though these models are incredibly impressive, they're still complex algorithms at their core.
Right.
They're great at processing information and generating text that sounds like a human wrote it, but does that mean they're self-aware? That's still a big open question.
Yeah, we shouldn't jump to conclusions about consciousness just yet.
No, but it's still pretty amazing that they exhibit these behaviors that we associate with consciousness.
It really is. It's fascinating and kind of scary at the same time.
I agree it's uncharted territory, and as we develop even more powerful systems, we're going to be facing even deeper questions about what it means to be intelligent and what it means to be human.
Okay, so let's put the big philosophical questions aside for a minute and talk about the practical side of all this. I mean, if we're creating machines that can kind of mimic human thinking, even if it's not exactly the same, how do we make sure they're used for good and not for bad?
That's the big challenge, isn't it?
It is. I mean, as AI becomes more and more integrated into our lives, we have to talk about its impact and, I mean, really talk about it openly and honestly.
Right. It's not just about the technology itself, it's about the values and principles that we build into it.
So it's not just about building smarter AI, it's about building ethical AI.
Exactly. We have to think about how AI is going to affect jobs, privacy, social justice, decision-making, all these big, important issues.
It's not just about the code, it's about society.
Right. And we need people from all different fields working together to figure this out. I mean, computer scientists, engineers, ethicists, lawyers, sociologists, everyone.
So we're kind of entering a new era, not just for technology, but for our responsibility as a society.
I think so. The decisions we make now are really going to shape the future.
So for our listeners out there who are obviously interested in AI and where it's all going, what can they do? How can we all be a part of this conversation and make sure AI is used for good?
I think the most important thing is to stay informed and engaged.
Okay.
There are so many resources out there, articles, podcasts, books, documentaries, all kinds of stuff that explore these issues.
Yeah, just got to do a little digging.
Exactly. And
Yeah.
don't be afraid to ask questions, challenge assumptions, get involved in discussions. The more we all talk about this, the better prepared we'll be to deal with the challenges and the opportunities that AI is going to bring.
It's like the future of AI isn't set in stone. It's something we're all creating together.
That's a great way to put it. It's both exciting and a little scary. But if we approach it with curiosity, critical thinking, and a commitment to doing the right thing, I think we can make it work.
This has been such an incredible deep dive. I mean, we've gone from the nuts and bolts of how LLMs work to the big questions about what it all means for humanity.
We've covered a lot of ground.
We have. Any final thoughts you want to leave our listeners with before we wrap up?
As we move forward with AI, I just want to encourage everyone to remember that these technologies have incredible potential, but we have a responsibility to use them wisely. So stay curious, stay engaged, and keep thinking critically. The future is in our hands.
Well said. And on that note, we've reached the end of our deep dive into the world of language models. We hope you enjoyed it. If you want to learn more, be sure to check out the show notes for links to the research paper and all the other resources we talked about. And as always, we love hearing from you, so feel free to share your thoughts, questions, or even your own moments with us on social media. Until next time, keep exploring the amazing world of AI, and remember, the future is ours to create